Nice to see you all. My name's Matt Ryer. I do the Go Time podcast. So if you haven't heard this, it's an English podcast where we talk about Go, and it's a free podcast, so you can just listen to it for free. And I blog about this tech also, and a lot of it comes out of our work in Pace. A lot of the technical blogs and things. So there's a lot of technical work to sort of do on a project, of course. And actually, that's what I'm going to talk about today. I'm going to show you some of the tech behind what we've built, some of the decisions that we took and why, and some of the philosophies that that lead us to those decisions. They tend to be quite surprising to people, and so that's why I quite enjoy talking about them. So hopefully, there's enough for everybody at all different levels to get out of this talk. Specifically, I'll give an overview of what Pace is first, but I want to talk about the architecture that we have, our technical architecture, and how that works and why we chose ultra simple architecture. We do have some remote procedure calls, and there's some interesting tech around that I want to dig into, and talk about code generation. We use code generation, and it turns out to be an extremely powerful thing if you get it right. And again, a lot of these things are possible to abuse, and I'll talk about that stuff as well. Of course, testing is a big thing for me. It's something I'm very interested in, and good testing for a project is what helps you evolve that product with confidence. If you've got good sets of tests behind you, you can be quite bold in your changes, and that's important, especially for us. It's an early stage startup. We want to be responsive and rapid, and we want to be able to react to feedback. Good testing helps us do that. And I'll also talk about how we do some background work as well. There's some background tasks which we will always need to do, and you want to do that also in a way that's simple and not too complicated, because it quickly does get complicated. So excuse me, what is pace.dev? Well, it's actually just a web-based project management tool. It's we were using Jira a lot, and we were using a few of these other tools. We use Slack a lot in previous companies, and we found that actually they weren't encouraging good practice. Slack, basically, it's an IM, it's an instant messaging app. So when you message somebody, you expect a reply. And if you don't get a reply, and sometimes we would turn Slack off so that we could focus and work without just hearing those little knocks all the time. Sometimes when we turned it off, when we open it back up again, we'd see that there are people there kind of frustrated that we were ignoring them. They feel ignored. And it's not their fault. It's not our fault. It was really the fault of the expectations that the app sets. So that was the idea. We wanted a asynchronous communication tool that also let us track work in a kind of familiar way. And so, of course, technically, there's lots of different ways to do that, to achieve that. So what did we do? Well, we have experience. Xiaozhong in the last talk talked about using Go because he enjoyed using Go. And that sounds like, it just sounds frivolous, doesn't it, when you hear that? But actually, I think there's something key about that. Whenever we do work, when we're using tech that we enjoy, or we're using tools that we enjoy, the work seems to be better. Certainly is for me. And that's why I would use Go. I even would use Go where Go probably isn't the best tool, the best possible choice, but it's something I enjoy and I'm familiar with, and I have fun doing it. So I think having fun, choosing tech that you have fun with, is something we should consider. Of course, in bigger teams, it doesn't always come down to that. You don't always have that choice. But actually, at Pace, we're a kind of tiny team. There's two of us building this, so there's a lot of freedom that comes in with that too. So Pace is a set of Go API services, so literally HTTP handler services, and we run them in Google App Engine. The nice thing about Google App Engine is that you can just you just upload your code, you upload your project, and it builds it for you. It runs the instances when they're needed. It scales those instances down to 0 if nobody's using it. Hopefully, we won't be using that feature very much, but it's nice for small and big projects. But in particular, if you're a startup, you only want to pay for what you're going to be using, and so App Engine is a good way to do that. There are, of course, other options that are similar kind of thing. But it's a sort of serverless approach, and it's nice for us because we get to write our app, and just with a simple command we deploy it, and we know it's ready for big scale. Because if we have bursts of traffic, we know that Google will spin up more instances to cope with that demand, and so that as a developer is very nice, particularly if you aren't into doing ops. Again, if it's not something you enjoy or you don't have that expertise on the team, it's nice to be able to just hand that off. We wanted the UX to be nice, and so it has a rich front end, and so we built that in Svelte.js. And if you haven't seen Svelte.js, it's quite interesting. It's kind of like React and Angular, except that it does a lot of its work at compile time. So instead of there being virtual DOMs and runtime things going on in the browser, the Svelte tooling kind of does all that work ahead of time. So for example, if you change some data in React, that's going to trigger some handler to run, which will probably have an array of different callbacks that need to be called. It will then do the changes. It then compares the virtual DOM to the current DOM and does a diff on that, and then it knows what to update. So it's clever, but of course there's work to do in the browser, which of course is that takes resource from the browser. And in Svelte, it doesn't do that. It essentially does all the wiring up beforehand. So if changing some data is going to have an impact in the app, it will figure out what impact it's going to have and kind of hardwire it at compile time. So there was something nice about that. Svelte also has a minimalist kind of design. So again, that appealed to us. Go has that same thing, the minimalism in Go. There aren't loads of language features in Go. There are just some core ones, and with that, you can build what you need. It means that it's easier to learn and easier to maintain code, frankly, because you don't have to dig in. Like in C++, you can override operators. So that means you can change what the plus symbol does on some numbers. And things like that. And sometimes it makes sense. Like if you've got your own custom type where you could add values together, you want to be able to implement that. But being able to override them on existing things, I think, is quite a strange feature to have in a language. So Go often will look limited to people outside Go, but there's great benefits you get from having that more simplified approach. And Svelte has the same thing. Svelte also compiles into static assets, which makes deployments very easy. So we build our front end, and that generates essentially CSS and JavaScript files. We then, using the G-Cloud, Google Cloud tools, upload all of that to App Engine, and that's where it's then served from. And App Engine even does static assets in a kind of special way, where it distributes them on the CDN so that your static assets will be very quick. They're delivered locally around the world to people. So again, that's quite nice, especially in our context, because we're building a tool. We expect to have people from all over the world using it. And we don't want it to be slow just because you happen to be in, say, Australia or something where your internet connection's not. So we use, they're the two main technologies we use. We use Makefiles. There are other options for that too. It's just something we're familiar with, but little script files to just run common commands. And then we use some of the services provided in Google App Engine. For example, there's a PubSub service. They have, of course, their storage for files and things. And we use a Firebase data store as well. So really, that's it. There isn't a great deal more to our application than that. The other thing that's worth saying is we use a mono repo, and that means everything, all the code for our company is in one repo. That includes the website, the blog, the app itself, and then any tools that we build along the way. Also, we'll just go into this mono repo. Again, this isn't always a choice that teams get to make, but if you do make this choice, one of the nice side effects is a change, a pull request can contain changes to the app, changes to the front end, API changes, documentation changes, tests will probably change too, all in one PR. And so when it gets merged, the whole system is advancing as one and getting better, hopefully, in one go, in one event. And you cut out a lot of the pain of synchronizing changes. Imagine if you have these projects distributed. Now we have to make sure we merge this API change at the same time that we merge this one, and maybe the documentation's in its own repo. And suddenly there's work to do to manage releases and things. If you have a mono repo and we deploy master, so everything in master is ready to be deployed. It's very simple. It's a very simple approach. And again, I think sometimes looks naive. And it's one of those things where this is how I used to do it. And then I learned how to do software engineering properly. And I would do all this complicated stuff and live with all that pain. And then I've kind of come all the way back around to, I'm just going to do it this way again and keep it all dead simple. That is a kind of common theme to to this talk and also our development at Pace. We will choose simplicity at almost any cost. And usually there isn't a great deal of cost. So I'm going to give a quick demo of the application itself so you can see what it is. Essentially, we have kind of inbox-like messaging here for conversations. They're asynchronous conversations. So the nice thing is you aren't expected to reply immediately. When you start a conversation in here, we know that people are busy and they'll get round to it when they get round to it. Of course, if you do happen to be online at the same time as other people, it works in that same way as an IM, and it's immediate. It has live feedback, live updates and things, but it isn't the expectation that we set by default. By default, it's async. So we really want to protect developer time there. You can see these are probably quite familiar. These are cards we have, and then you can go and look in a card, and there's comments, and there's different statuses you have. And the same kind of thing with conversations. We have conversations that you can chat about, and you've got reactions and comments and things. All quite familiar, I would hope. We have a few other features, like we have this showcasing capability where we want to let people show off their work. But essentially, you could imagine that is a somewhat simple web application. And then I'm going to dig into some of the details of the technical things behind that too. Before I do, I want to just say we work in a kind of strange way at Pace to some people, and that is that we pair program almost exclusively. So pair programming, if you haven't ever tried it, I do recommend trying it. It has some strange benefits. Firstly, it's two minds working on the same thing at the same time. That can work really well. It does for us. You spot typos very quickly. You get to sort of validate. It's almost having a linter happening, but not just checking your code, thinking about the kind of impact, the whole system, really thinking about the impact of what you're doing and how that's going to manifest. And that's difficult to do when you're focused on the particular problem. When you're looking at that small problem, it's quite difficult to see what impact that's going to have. Having a partner helps with that a little bit. And then there's other benefits like, the knowledge is shared immediately. So my business partner, David, knows as much about the system as I do. And so we're both kind of empowered to go and look at any part of the system. Again, you can do that when it's small, but it does apply in larger teams as well. Knowledge transfer and maintenance and things is often a difficult thing to get right. And pair programming helps with that. So I wanted to make a quick point about that before we get on to talking about our architecture. One thing I liked from Sal's talk just now was this thing, how very simple rules, when applied kind of in aggregate, can turn into something quite different. This pattern emerged from a very simple little rule. So if you think about that from a technology point of view, any package, every component, every function, and every variable, everything we add will have an impact. And it's not an impact that's easy to see just by focusing on that small thing. So if you think about the rule that we looked at, which is the binary rule, you wouldn't be able to imagine, I don't think, this pattern from that. And that's really what we're trying to do when we design systems. We're trying to imagine what's this aggregate shape? What's the shape this is going to produce? Not the shape of the individual pieces, because they're quite simple and small and easy to see. It's how they interact together and how that also interacts with real people and things. So I really appreciated kind of this, and anyone that didn't see the talk, if you can, I recommend it. Okay, so our architecture is simple. There's no doubt about that, and I can demonstrate that by showing this is the mono repo folder. So we have this paste.dev repo, and here's everything we have inside that. So you can see, look, there's the blog. This is our website. We've got some tools here, some other experiments. There's a few things, configuration files that you need for App Engine, like this dispatch YAML is how you tell it which routes map to which components. So you can see there that we do have different components, but they're all inside the mono repo, and they just distribute like that. Where we have our website, we, as you can see, have static HTML files. This, again, isn't something that most people would consider kind of high quality software engineering. It's just a static HTML file for the homepage. And it is, look, it's got all the styles in there and everything. You'd think that this was written by somebody just out of college that hasn't got much experience. In fact, that's what people have said about this when we show this off. And I take it as a compliment in some ways because of the simplicity of it. And that's kind of one of the messages I want to get across is don't feel like because something's simple that it somehow isn't proper engineering. You know what I mean? Proper engineering is really about keeping things as simple as possible. So if an index file, index.html file will do, then you don't need anything more complex than that. And we've done the same thing with our application architecture. In here, I opened the application. This is our app folder. This is the actual, the Go services and the front end. These are those two things, basically, and a few other bits and pieces. And we just have one folder here for our pub/sub handlers. These are our public handlers. And I can show those off by showing you the roots file. So you can see in here, we're using this sort of standard muxa. This is the HTTP handler pattern here. We're using the handler func, or we have all these functions which are just scattered about here. So notice we haven't broken all this stuff down into little packages. This is all just out in one folder, and we use file names to group things up. So you can see that all these handlers are handling pub/sub. There's a few other handlers that handle different things, and there's a Stripe handler there, the webhook Stripe handler. That's very easy to see by looking at those files, I think. Again, people will say, this should be broken into packages, broken down into folders. You should have proper architecture. You need to be able to have architecture diagrams and things. And that's true at some points and in some contexts. But don't assume it's true, I would say, because it may not be. And it's a bit like trying to picture that pyramid shape. That's a very difficult thing to imagine when you only have these components, these small pieces to look at. And the equivalent would be to try and imagine what folder structure we should have to house this thing. It's quite difficult to do. With the more experience you get, the better you get at doing that, I think. But you really end up making a lot of assumptions, and sometimes there are things that you really have no business making firm assumptions about that early. So our approach is flat folder structure, and when or if there are problems with this, then we'll tackle that and we'll refactor. But we aren't going to start there. We're not going to start with a big complicated architecture. We do have a little, and we have this API package. And this API package basically encapsulates all the API, all the services. Pace works. It's got backend Go services and a rich front end, and they communicate through RPC calls. And I'll talk more about that soon. That works. It works in a really sort of simple way because you just have front end and back end. Of course, it's possible to break an API down by all these different things. Like we could have cache services, we could have billing services, we could have file services, all as their own individual components. And some people do architect things like that. There's pain that comes with doing that. And, if you think about even just packages having import cycles and then strange dependencies and dependency work you have to do to figure out, well, suddenly now this thing over here and this thing have something in common. So we're going to try and find that commonality and break it out into a third thing. And then when another thing comes along that kind of needs that, it's too tempting to just use it. And, it doesn't quite fit. So we add things to it. That is how you end up with kind of Frankenstein architectures that are difficult to maintain, and you get scared and worried when you go and work on certain bits of it, and that is a bad feeling. We don't want that feeling. When you have everything like this, you just don't have that problem. We can give these services to each other in a flat way, right? If this file service needs some dependencies, which it does, they're just fields in this struct. Look, so we've got a file service. It needs the internal file service. It needs the org service. It needs the text internal service, and they're spelled out in a strongly typed way. So there is no way to get this file service that we need without providing the dependencies. So that means that the Go compiler is going to be helping us make sure we've got this right. And it becomes a no-brainer. So these sorts of simple little things, they really help when it comes to actually maintaining code, because you don't have to fight with this architecture that you dreamed up too early. It's all just flat. Again, and I forgive people for saying this, we did show this off, and the first thing somebody said was, it looks like we don't know how to architect things. That's basically what they said. And I think that drives a lot of people to these complicated architectures. So I want to make the case for this. This might well evolve. It might well change. And I could imagine if, for example, our one of these services, let's say the messages service, or let's say comments service, I could imagine the comments are used a lot more than other parts of this system. And so you could make a case for having that comment service broken out into its own thing. Well, that's still very easy to do because it's just a type. So if I wanted to pull this comment service into its own component and deploy it independently, because that's really the value of having microservices, is you can control one of the value props is you can control how they're deployed. and you can scale independently a certain part of the system that might get used more. Well, that's certainly still possible. They're still sensible to group functionality up by type, like we do in Go. So yeah, that's the thing. It's still flat. We don't try and build complicated package hierarchies, but there is still structure here. It's just that it's emerging rather than us trying to design it by force. We have a few cases of packages which we do pull out, and this allows us to keep them neat. Sometimes this makes sense to us, and sometimes we actually regret this. Sometimes we'll create a package just because cognitively it's nice to have a clean space to work. And then later we say, we aren't going to use this package elsewhere. We aren't going to open source this thing. So maybe this just goes in the general code and there's no benefit. But sometimes it's just nice to have a sort of clean sort of storytelling as well in your code. And that's quite a good reason, I think, to pull things into their own packages. So we have this file. This is just providing some string slice help. Like we have this in function, which checks to see if a string is in a slice of strings. We have a without one here, which is going to get this slice and remove a string from it. So this is kind of just string slice manipulation. It all kind of belongs in one place. And we can unit test it nicely as well. So we do have some examples of little packages like that dotted throughout. The next main area I want to talk about is our remote procedure calls. So as I mentioned, Pace is a rich front end, and it communicates through a series of API calls. And you can see them in the browser here. Try and make this bigger. So you can see here, look, we have, it's very easy to see, by the way, which service and which method is being called here. This from a usability point of view really helps when it comes to debugging. So you can see that we have this pace.dev/auto tags service.getAllTags. So that matches our code. It's very easy for me to come and find the tags service. And in here, there will be a method of getAllTags, which I can find for you here. So again, there's no reason to hide things unnecessarily. That's another thing that I think we try and do. It comes from wanting to protect internals and allowing yourselves to change them without affecting the outside world. Well, this is an API that's being consumed by this front end. It's not a public API, so we don't have that problem. And so we'll opt again for what's the most simple and what's the most obvious for us when it comes to debugging it. And having a good URL is a great start for that. So this auto piece here is actually a clue as to how we're doing this. We made a little RPC project. And we made it because we looked at gRPC, we looked at a few other options, and they were either the complexity was such that we didn't feel like we wanted to take on the burden of learning new technology. There were a few technical problems with gRPC which may have gone away now in App Engine. It used to be that in fact, you can't open your own ports. When you deploy to the Google servers, they really are controlling which ports are open. They do a lot of routing and things. With gRPC, because it's a binary protocol, a lot of the tooling wanted you to open a port that was explicitly for gRPC communication. So in some contexts, that's just not okay. And there are some great projects to get around it, like gRPC Gateway and this JSON gRPC things, but they just weren't available for us at the time. So we rolled our own little project. This is another thing which you can do when there's only two of you and you're a tiny team. Often you may find yourself in bigger companies, and there may be lots of people having to kind of work on services early, that would change how you make these decisions probably. We are in a position of privilege in some extent, because we don't have a lot of the pressures that are faced on other projects. And we are both acting as the product owners here and the technical owners. So by fusing that into one, we're in a different situation. We can make decisions based solely on technical things sometimes, and likewise purely product decisions other times. But I think everybody should get a say in those things too. It's important that that technical expertise does make its way into other parts of the business. So even in bigger teams, these things matter. They're still important and worth having these conversations. So Oto was born out of the need for us to want to have just a standard way of describing RPC services, essentially. And since we love Go, we designed it around Go. In fact, you describe your services using Go interfaces. So gRPC has protobuf, which is this kind of, looks a bit like Go anyway, but of course it isn't, and has other features in there that we didn't need and don't need. But what we like about this is we can describe a service using language that we're very familiar with, and using tooling that we're very familiar with. Our definition files are working Go code. We get compile time checks and help. So let's have a look at the comments service here. So if I, by the way, make a mistake, if I put request to there and save it, you can see I get my IDE is telling me that's an undeclared name. It's no such type. So I've got strong types here when describing my API, which is very nice. Every service method, every service, I should say, is an interface. So you can see that there's this comment service here, and it has a request type and a response type. And we follow this pattern of just using the same name and then followed by request response. So actually, there's not much work to do when it comes to describing the service. Let's look at add comment. So we've got this add comment request here, and there's a type, and it's just a type in here like you would with Go, and it has fields and just uses all the Go fields that are allowed. You can use other types here. You can use maps, anything really that can be expressed in a JSON way, you can use. And that, again, is kind of simple. We're aware of JSON tech. We know how to use it. We know what it can do and what it can't do. So it was a great choice. And if you think about this kind of application, it's kind of perfect. RPC is a sort of perfect design choice for this particular case. May not be true in your case, but may also be true. So everything has a request and a response and is very easy to see. And we can just, by reading this file, we know our API. Oto then uses templates to take this. It parses it using the Go packages. The Go has a series of kind of Go code parsing capabilities. Go used to be written in C, and then once Go was written, they then rewrote it in Go, which is a very strange thing to happen. What that means is there are some decent packages that allow you to process and understand Go code. And that's what we do. We process this definition package. We pull out all the interfaces and all the type information, and we build essentially an in-memory model of that using our own types. And Oto, by the way, is an open source project. So if you go and look in parser.go, you can actually see those and those types. So you can see, look, there's a definition there. It has a package name, some services, different objects, imports. Because it's Go code, you can import other Go code. So we had to solve imports as well. A service just has a name and methods. Method has an input and an output object. As I said, we dramatically simplified everything here. An object, well, inputs and output types, they're field types. So we did have to also model types in this. But anyway, you end up with Go strongly typed structures describing that API, those services. And from that, we render Go code using various templates. So as an example, we have this server Go template. And this essentially, you can see it's kind of Go code, but it has these templating things injected into it, and loops and things like this. So for all the imports there, we add the import. And we're basically writing using templates to write Go code. So this is probably the weirdest part of Oto, because it's kind of meta programming. But what you end up with is very easy, very nice to read, and very simple Go code, which you can then use in your project. And that's what we do. So these templates will generate the server and the client. You can see the client, the JavaScript client. And all it's doing is encoding. It takes, it creates a class. It's literally a class here in JavaScript. For each method, we add a method. And you can see there's some string manipulation to make it feel more JavaScript-y, like, because Go, doesn't use caramelized formats, So we try and make the code look like the language that it's generating for. And it's just doing the common things. You can see it makes the request here, sets the headers, creates the body from the input type. Then it actually uses the fetch API here to make the call to the server. If there's a response, then we get the JSON back. And if there's an error in that JSON through this specific type that we manage, then we throw it. And it uses the promises API in the front end. So if you're not familiar with that, don't worry. But the net result is we have a server and client that's just generated for us. And then I'll show you literally what gets generated, actually, because this is quite cool. We have here this Oto-gen file. This entire file is generated by Oto, and you can see it's quite long, 4,000 lines plus, and essentially it just contains our implementation of what we want the Oto services to do for us. So we generate an interface for each of the services. In the definition, there was already an interface, but our Go code needs a few more things. So it's a different interface, and these are in different packages, so it's okay. So we have an admin service interface here, and you can see that each method gets its own method, but we've added the context here, and in the response, you can also return an error. One of the nice things about Go is the explicitness around error handling, and we didn't want to lose that even in our API layers. So when we write Go code, when we implement these services, we're able to just return errors in the normal way, and they'll be handled in one place in the consistent way. So that's quite nice. And that's something that we added after a few iterations of this. So again, even with this wasn't just our initial design. This itself has evolved. Taking the context in is quite useful, because sometimes there's some long operations, some work that's going to go on, and if the user has cancelled that request in a browser, that can just mean they've clicked on something else or closed their browser. That context will get cancelled by the Go HTTP package, and you can abort the work and you can save yourself some time. There's also timeouts and things that you can enforce using this pattern. And also, sometimes other services that we use need context as well. So it's nice to have this kind of as a common pattern that we have. Well, now Oto has generated that for us. We just have to implement these interfaces, and then we can wire them up. And we wire them up using these helpers that are generated again for us. So every method actually gets its own handler. And it's just using the Oto HTTP package to decode the request into the specific type. Look, that's a special type that we've talked about. We then will, this in this case, it's calling the billing service to get the billing info. Notice this is a real HTTP handler. So this is the thing that's listening for that route. We then call the real implementation. We know we're going to get back a strongly typed response, and we just encode that response to the server. So this is simple. When Go gets generics, it might be possible to have this kind of code written once in your project. But because everything's strongly typed in our project here, we needed this for every type. So that's why we have it. And with code generation, it's easy because you sort of just have to write it once in a weird meta way, and then the rest of it's generated for you. It also generates these register functions. So you can see that we're going to pass in an Oto server. We're going to pass in the implementation. So again, this is generated, and that's using the strong typed service name there. This is the interface. So what this does is this is creating the comment service server type, and it gives it the server and the actual implementation, and then it just uses this register command to map essentially the inputs. And that's how then with the routing, it's able to take the web request and turn it into a Go method call and back out through that. And that's it. It doesn't do too much more than that. It's nice that the handlers are real HTTP handlers, because that allows us to then use usual middleware and things that we might already be familiar with in our code. And we do that for auth and things. Wherever there's commonality, we can wrap these. So we're left then in the comment service with this constructor basically returns the interface, because there is an interface. And that means if we do anything wrong, like maybe I called this delete comments instead, you'll notice that there's some problems with that, namely this one. And it's saying you can't use this type because you don't satisfy the interface. So we get strong type help throughout with these services. And so that's what turns into, excuse me, let me find it in here again. That's what turns into these calls. They're just, and in the front end, it's just like calling local JavaScript functions. They get routed through this to the back end through the HTTP stuff, and down through that little stack into a method, and the response comes back this way. So if I were to ask David, let's say, where we should put a new service, the answer's obvious. We put it with all the other services. If I were to ask him let me just fix that. If I were to ask him, how should we model this? How should we represent this? It's kind of solved already for us. And so that's kind of a nice shortcut that we get. And it's working really quite nicely so far. So the other thing that's worth saying is that we also write and maintain our own templates for Oto. So there are some in the repo, but the point is you basically write your own templates so that it does exactly what you need it to do. And there's a wider sort of philosophical point around this, and the same thing applied to our blog. We had the choice of using static generation tools to build our blog. And Hugo was the one that I was looking at initially, because it's written in Go. It's extremely fast. It's quite mature now. It's got a lot of users. When we started to use it, it was complicated for us. There was a lot of little things that we felt like we had to learn. You had to learn how to use the tool, and that was a barrier. And we already know how to write Go code. And so in some cases, we took the choice of rolling our own, where you could see the case being made for using an existing tool off the shelf, because naturally we always just want to write everything, and it is worth resisting that. But when you do write it yourself, you can write exactly what you need. So there's a trade-off there that you do have to be very careful with. But what it means is you have full control. I'll jump quickly into the blog because I just want to show that. It's a similar kind of point here. We have this blog generation tool here, and this is essentially just a main file. It runs through all of the blog markdown, which is the source content. So I could say I could find a post here, find a good one. So this is a post about dynamically generating social media images in Go. It's just a markdown file that has images. So again, when you put this in GitHub, these files get rendered quite nicely. They're quite easy to work with. We already know Markdown, and we're just using the same kind of things that we already use today. So, we already know how to do links and things in Markdown. So having a blog that allows us to write it in the same way kind of gives us that benefit. So our tool will basically walks this source folder and looks for these markdown files. This is literally a .md file at the end. And then whenever it finds one, it reads it. It reads the initial bits at the top, and this becomes kind of metadata about the post. And then it uses templating again to render the actual post itself. So here's what gets rendered for dynamically generating those social media images. You can see that not only do we generate the raw HTML, so again, it's a static HTML file in the end that's going to be served. These are the easiest things to serve because, particularly in App Engine, and there's other options that do it. When they use CDNs, this static content is lightning fast all over the world. So it's very appealing to be able to deploy a static thing. The alternative would be to have a blog that's dynamically mixing templates and things at runtime, and then maybe have caching on top to then give you some of the protection and some scale. Static assets are even simpler than that. And we do things like this. We generate these little social media images, which these show up when you share these blog posts. And so, for example, here, you can see it's got the logo on it. It's got our blog URL and then this title. When you share that, say on LinkedIn, and you see the little cursor blinking and things, it's a more engaging experience. And we've noticed since we had these, we get more traffic. This is quite meta because this is a blog post about how we generate those images. So if you are interested in generating these for your own thing, we wrote a blog post about it. It's actually here. You can either read the HTML or go to pace.dev/blog and you'll find it there. Okay, I mean, that's essentially the blog. The reason I wanted to show that off is really just to make that point that yes, this was extra work for us. So it was an investment. It's not free, but we have complete control of our blog. And if we need it to do anything that would have been difficult in Hugo, we can do it very easily. Again, you have to be careful with that because there's trade-offs everywhere. But that's really the power of code generation. And I believe that was my next slide. Yeah, so we use code generation quite a bit. And even with generics, we still would use code generation because, for example, Auto, taking those service definitions and having the type safety there, that's a code gen story, really. The reason that works is because of code generation. If we had to write the plumbing for every method we added, that wouldn't be very nice. We wouldn't be very keen to add services and enhance the system. So we'd probably avoid it. Another area that's I'm particularly interested in is testing. Testing is basically how you're able to sleep at night. You deploy. I can deploy Pace anytime, and I'll deploy it by typing that make deploy. This now is going to go and do a build, and it's going to deploy our app. And the reason I'm so confident in doing this is this little bit here where it's now running all the tests. So you'll see here in a minute, it's going to run through and run an entire suite of tests. If all of those tests pass, then I'm confident we can deploy the application. If anything fails, then this deploy actually will be aborted. So testing, if you do it properly, can really give you the confidence to move in a robust and quick way. Actually, it turns out to be very it speeds things up quite a lot because you don't have to do as much work worrying about unexpected side effects to your changes. Without tests, you would have to just manually test it. Basically, you still have to test it, you're just doing it manually. So testing is something that I really believe in, and we took, I think, quite a sophisticated approach when it came to testing. We don't do 100% code coverage. We're not those types. I actually think if you have 100% code coverage, you've gone too far, because what's happened is your tests have become so brittle because they're so tightly bound to the implementation of what you've written that any change is going to just break lots of tests. And that's not great. You want to be able to kind of change your internals while the behavior's remaining the same, and then therefore that not breaking the tests. So it seems counterintuitive, but I would say 100% code coverage is an anti-goal, should not be something we shoot for. In fact, we don't count code coverage because we don't find it to be particularly useful. In some contexts it is, right? If you've got a little package that's doing string manipulation and you know every case it has to support, maybe that's different. For an application like this, 100% code coverage would kill productivity. We have unit testing where it makes sense. Notice here, not every file has its own accompanying test file. And again, that would be an alarm bell to some people. But that's because we've been very selective about where the testing is and what testing is appropriate for different parts of this. We have this app URL parsing thing. So if in Pace you paste a link to a comment or a card or a piece of work, what we do is we notice it's a Pace URL and we parse it and we turn it into something that looks nicer. We go and get the title of the card and put that in so that it's a nice experience. Well, that sort of operation is perfect for unit testing. We know the inputs and outputs that we expect, so we can write code like this. So you can see that we've got this. This is the URL for a card for URL unfurling. Has a card ID there. And I've got then a method I'm calling, and then I'm making some assertions about what I get out of that. So it's a kind of true unit test. And we're literally calling the method that we're going to be calling. So it's nice. By the way, this is a Testify. It's like a mini version of Testify. Testify is a testing framework in Go, but it's massive. It has a lot. It does a lot, and so is a kind of minimalist version of Testify. So I recommend using something like is. It just has a handful. If you look at the API, it has a handful of methods rather than 80. I don't know how many Testify has, but it's a lot. It might even be 80. I was joking, but I don't know. Okay, so this is essentially making assertions about the outputs as you'd expect. And so we do have this kind of testing, and I can run these tests. In fact, these tests do get run as well when we deploy, and they're a different kind of test. But they're good. They're good to have, and sometimes they're perfect. The other type of test we have is what's probably more of an integration test to our API. So what we do is we spin up our service, the API service, with a Firestore emulator. So this is what spins up locally on my development machine. Again, we both have the same machine, so we don't have other problems to deal with that you do have legitimately when you have more people. I recommend looking at Docker test, by the way, something I discovered recently, which is a good way to achieve this if you don't have the same machine that you're developing on, the whole team. But we do. So we spin up this emulator, we spin up the API services, and we actually generated one of the other templates we have here is a Go client for our services. So this is literally, if we can decode this, you can see that this is actually Go code, kind of, that's going to make a real HTTP request to the service, and then it decodes the body, and you see that everything's strongly typed still. Look, because we're going to use the proper output object type name here as the response. So this creates a client which is strongly typed. So the nice thing is, if I go into here and find our comments service, I can do comment service dot, and I have the help in the IDE. Notice it looks like very similar to the server code that was generated. It actually isn't the same, although I think the interfaces are identical, because I still want to use the same strong types. If I add the comment here, I have to pass in an add comment request. I will get back an add comment response. So I'm now in here writing test code using strongly typed client that I generated from those same auto definitions that's generated the server code and the JavaScript client code. I get to do that in a familiar way and really become a user of the API in the same way that the web front end is a user. There is an extra piece that allows me to specify which user I want to impersonate, and you can't have that in the web API one. That would be a massive security problem. So I have it here just for ease. We can break the rules because this is internal code, you see. And I'm just writing test code like here. I'm create a card. I check there's no error. I'm passing the org and the team that I want to create the card in. I pass a title. When it's successful, after I've checked there's no error that's come back, I grab the card ID, and here then I go and add files to that card. I'm getting the org here, making sure that the storage used was updated as I was adding files. I'm actually writing code and thinking things through as a real user. And that is a great way to have an automated way of being sure that your API is behaving as you want it to behave. If I were to nip in somewhere and break something, which I'm more than prepared to do, let me just return an error here unexpectedly. I think I can do that. Oh, that's complaining because this is now unreachable. Let's see if that's just a lint error or, oh no, I deployed it. Don't worry. See, I just did make deploy then. That could have been disastrous if I didn't have test coverage. You see how nervous I'd be in the terminal if I didn't have these tests protecting me? I wouldn't, I'd be so careful about everything I typed. I don't need to. I can just be like, yeah, deploy. I've made a mess, deploy it. And it just won't, luckily. Okay, so what's going to happen is this will run to that point. When it hits the point in that test where it was trying to update a comment, that's going to fail. I suppose you don't really need to see this fail to believe me. These tests are running. We normally run these tests in parallel, but we were working on something and we took it out. That's why these tests are being slow. Okay, I can't be bothered to wait for it. I'll just abort it and take this out. Get the idea. It's tested because this will at some point call update service, and if any, even if the fields are wrong that we get back, it'll fail. If there's an error, of course, it's going to fail. And sometimes we want errors back. And again, just like you write normal Go code, you know, it's easy if I left the title empty when I added a comment, and that was an error, then I could assert that that error is what came back. See what I mean? So you can actually properly write good, strongly typed test code for the service. And when it's deployed, we know that it's going to be done in a kind of safe way. The final thing I want to show off is how we do this background work. One of the other key parts of this, you know, it is dead simple. It's just the user does something in the browser. The browser makes a call through Auto to our backend. The backend does the work. Did I show a proper implementation of a service? Because if not, I will. Let me find the comment service, and we'll just find add comment. So we check, we get the current user here. This is the implementation code. So notice this wasn't generated for me. I still had to. That'd be good, wouldn't it, if it just generated the actual implementation as well, and you just have to write Go interfaces. One day we'll get there. Until then, we have to write the implementations, annoyingly. So you can see it does some basic things. It checks to make sure that the user has permission. It's doing some work there for files. Eventually, it creates this comment entity and uses the store to put that comment entity at this particular place. And we use Firestore here. This is a slight abstraction we have over the store because sometimes an operation, because it's a remote service, you know, that can sometimes fail. In fact, all things can sometimes fail, and we sort of expect it to. And we design around it. And so this little abstraction we have for the store, if we try and put a record and that fails for whatever reason, the API lets you decide whether it's a temporary error or if, in fact, you know, it was malformed or something. If it was just a temporary error, we just have a little back off in that store that just tries again. So the net result is when this returns here, as long as it returns with no error, as long as it returns nil, that's been successful. It may have tried a few times there. So that's quite nice. Little things like that. And we only added that after we had a few times when it was failing. You know, we don't try and abstract all this stuff too early. You know, for example, getting the current user ID and checking that they're in the org, that's something we do in probably 95% of the cases. So you could put that into a middleware. The problem is there are a couple of times when we don't do that. And so we actually would rather just copy and paste this. You will notice it's kind of is the same in almost all of them. Programmers will naturally, that feels wrong. We want to dry that up. But actually, it's better sometimes to leave it because it's explicit. Like if I come to add comment and all it's doing is the comment things, I might be surprised by some behavior because maybe I don't have permission. I'm getting strange errors. I can't see that here. So one advantage to just having everything out like this. Obviously, these are method calls to other services, so it's not the actual detail of it. But having those layers of abstractions hide things, and you have to then go and find it. A bit like the pyramid from the talk before. You don't. It's hard to see that shape when you're looking just in the detail. So what you can do, whatever you can do to help yourself, your future self, then you should do it. And that's what we do. Once this is all done, we return the strong type. There you go. So that's the thing. The other interesting thing is when you comment on something in Pace, we want to let other people know that you've commented. There might be other people interested in a piece of work for whatever reason. If we did that immediately, it means what would happen is you type in a comment, press enter, and you'd see the little loader for ages, because it's going to not only put the comment in the data store, it's going to have to go and load all the people that are interested from the target, the thing you're commenting on. It's going to have to iterate through them and create records for them to notify them. If there's 100 people or even 1,000 people interested, that is just not okay. You can't ask the user to wait when you post a comment. It'd be like doing a tweet, and then the more followers you have, the longer you have to wait after a tweet, because it's going to go and update all the followers. By the way, that is how Twitter works. It does, in fact, do that. But of course, it does it asynchronously. It does it in the background. And that was the other major thing that we needed. App Engine has a PubSub service, so we're able to use that. And we have a slight abstraction over a couple of bits and pieces. Slight abstractions that we added after the fact. Again, strongly typed here, we get to just say, publish this inbox item deliver. This is the operation that tells everyone, updates everyone that a comment has been made. This will literally just post to the PubSub API and return. So even this is quick. We still do them asynchronously, because in this case, look, we update the search index at the same time as well. And then we have our set of PubSub handlers that we saw earlier. And here we have actually it's the inbox service has the deliver. Now, what's happening is we issue that message. We'll say this comment's been created, so we need to deliver this update. The App Engine PubSub will actually take that, and the way it works, because it's HTTP, it will essentially make an HTTP request to the URL that we told it to use, which is going to, through the routing, is going to line up to this particular method. So that's the flow. It goes from the PubSub service, it hits a real endpoint in our service. We then go and do the work. And this is a background task, so there isn't a user waiting for this to happen. This can take up to, I think, 10 minutes or something. So, again, you may decide to do batching and things. If operations are going to take longer than 10 minutes, they're not taking longer than 10 minutes, so we haven't done that. But this then speaks HTTP. If you return an error, it'll retry. So it's quite cool that if one of our comments just fails to get delivered for whatever reason, I mean, things fail all the time in computers, so that will happen sometimes. The PubSub operation will try again. And because we designed our systems to be idempotent, which essentially means no matter how many times you apply that operation, the end result is the same as if you just applied it the once. So a very important concept, it turns out. Because of that, we don't mind if something fails. The system will just retry. We aren't going to be delivering multiple times to people because the way we designed it. So if it's already been delivered, it's just a kind of no-op. It won't look like it's been delivered again. So given that design, we then don't mind if these things happen. In fact, we expect them to. And it becomes kind of self-healing. If there are mistakes that happen because the things retry, or maybe it's a lower priority and you don't really have to retry. Maybe it's okay if it fails. That's another one where if you tell that to a product person, it's fine if this fails. They will not agree with that. That does not sound sensible. But actually, if you think about a conversation happening with lots of comments, if one of those comments failed to alert somebody, then and there's a conversation happening, the next comment might well be successful. And so most of the time you're okay. So it's kind of that strange sort of thinking of like, probably we're going to be okay with this. This is probably okay and probably good enough. That becomes very common thinking, because it's about living in the real world, really. Of course, we do everything we can to make it work every time, but it's computers. It doesn't. And I think that's essentially it. I'll give a quick summary of what I've gone through today. So yeah, we keep everything we can as simple as possible, to the point where other experienced Go programmers would potentially look at it and say, "No, you're doing this wrong because you might have these problems in the future." Well, yeah, we might have them in the future. We don't have them today, and that's when we're building these things. So we do defer a lot, technical problems and hard things. It's a kind of balancing act. If you do that too much, you can get yourself in trouble. But I think done in the right way, it's such a nice approach, because everything's simple, and then the knock-on effect of that is it just keeps paying dividends again and again because it's simple. And then you make things more complex when you need to. Yeah, it's worth saying we are a tiny team. So having said that, this is how I've worked in bigger organizations, but just broken teams into smaller teams and then kind of worked like this. But there are challenges and different things you have to care about as you add people and as you add customers and things. Things do change and evolve, and that's part of the point, is that that's what you expect, and that's the time to make the decisions, because you've got all the context. Trying to imagine those structures up front, I find to be fun, but often you're wrong. Very often you're wrong. So maybe don't do it yet. Rolling your own components gives you absolute control. You do have to be careful. You can't just you don't want to reinvent the wheel. So, you want to make sure that you are using your time wisely. But when you have absolute control of something, you can make it do exactly what you need it to do, and do that really well. I love our blog, the way our blog looks and works. It doesn't have anything in there that we don't want in there. And there's something nice about that control that you can have if you really care about every pixel. And again, it's a point of privilege. Not everyone's in that position. Our structure is flat and boring. It's just a folder full of Go files, but it completely works. We've got a lot of code in there, and the IDE has not slowed down. None of the tooling's getting slower. Running the tests then was the slowest they've ever run. Usually it flies through them. And that's because we turned off the parallel processing bit. So yeah, flat structures and keeping things simple, but expect it to evolve. And when you learn, oh, this isn't right, it's not that you were wrong before. That's another thing. Like, I think, especially junior developers, you feel like we learned later that this was the wrong way to do it, therefore we should never have done it. And that's wrong. We can't predict the future. You probably did the right thing at the time. The fact that you changed it after is really only possible because of the journey you took. So we have to not be too hard on ourselves with those things. And in team environments, you've got to have a culture that allows for this, because this is how software development happens. I'm never very impressed when somebody says, this is exactly how we need to do it. This is how it's the only way to do it. This is the right way to do it. None of that's ever really true. There aren't really right and wrong ways. It's much more complicated than that. And the same thing applies for our working practices too. Occasionally, we will break work up and work on it independently. Mostly, we pair a lot. We pair almost exclusively, but sometimes we break it up and do it. So we're kind of flexible and relaxed, and that's kind of an approach that allows us to be quite rapid in our engineering. Thank you very much indeed. I would love to hear some questions if there are any.
One is on Octo.
Right.
So that's Octo. Yeah.
Okay. So the question is, does Otto employ a binary protocol? And the answer actually is no, not yet. At the moment, we have this Otto HTTP component, which is actually a JSON HTTP implementation. But what's interesting is, because they're templates, it's very easy for us to change this. Actually, in this case, because of this package, we could add a binary, and probably maybe will. The reason we haven't so far is because we like in the browser to be able to just go and have a look at the data that comes out like this. You know, we can click around and debug it and even make requests in a very easy, familiar way. So we're still in that phase of this. I think as this is running and as more customers come on board, we may find that there's some savings to be had, by doing something like that. Probably there isn't a great deal of overhead in marshalling and unmarshalling of JSON in this kind of system. If you think about it, it's rare that people are going to be clicking loads. But at scale, our intention is to measure. We measure a lot. We measure what's happening and where time is being spent, and then we'll go and tackle those problems. So if indeed we're spending a lot of time just marshalling and unmarshalling JSON, then the next thing, that a little project for us, would be to add a binary support. You could even add gRPC to Otto, by the way, and just use, because you can generate anything really, and just use the Go interfaces to define it. You probably wouldn't do that, but those options are open to us because we control it. And the design of Otto really was that, so that you take the templates and do what you want to do with those templates. So anybody could contribute if they wanted to. This is an open source project, by the way, a binary version of this. And it might be something we do as we might just stream it and build it just for sort of fun, because it's quite a fun thing to do. But so no, it's actually, for the reasons I've talked about, HTTP JSON, because it's familiar, it's simple, and it's good enough for now. But we can improve it later if we want to.
Okay, thank you, Matt. The last question is this, about templates.
So how do we check that templates being used are going to generate real valid code? And yes, what's the process of that? Well, the process is, if I show you our make file, in particular, the Go code is a good example, because we have gofumpt. So what's nice about this is I can use the Otto command to generate the server. Actually, it's this server file that I showed earlier, and then I gofumpt it, and that not only formats the code, but actually, if there's any errors in there, it reports the errors too. So you are getting quite early feedback, getting a quite early feedback loop there. And then it's a case of, after that, it's about then the testing, making sure that the testing works. But because these are strong types, you almost can't go wrong, because you get compile errors. In fact, they happen in the IDE. I'm not joking. If I go into this comments and added monkey, as a method. I'll just copy these types. If I then do my gen auto, generate the auto service, you can straight away see, look, there's a problem. And the problem is, it's trying to use this comment service where it shouldn't be allowed because of this. It's missing the monkey field. So it turns into a compile time exercise, and you can't get it wrong. It's cool. As far as implementation goes, of course, we rely then on our testing and our tests to check things. But again, our tests aren't checking the implementations really. They're just using it as an API. They're saying, create this card, give me the card ID. Now add a file, get the card. They're talking in those terms. If we changed how we did that in the server, these tests wouldn't break. They just keep working, hopefully.